And now we're going to look at how to do a confidence interval for the difference between two means. Our point estimate is found by taking the difference of two sample means plus and minus a t-score times a standard error for the two. It's based on the degrees of freedom that we saw for the hypothesis test. So again, this is not something that I'm going to ask or expect you to do by hand. So suppose we want to test the mathematical aptitude of grade school children. We give two different classes the same math test and record the results. The first class is a third grade class of 30 students. They score a mean of 75 with a standard deviation of 3. The second class is a fifth grade class. They have a mean score of 85 with a standard deviation of 5. Construct a 95% confidence interval for the difference in the mean test scores between the third and the fifth graders. So I'm going to go ahead and identify everything. So our third grade class contains 30 students. They have a mean score of 75 and a standard deviation of 3. The fifth grade class contains 30 students. They have a mean score of 84, standard deviation of 5. We want a 95% confidence interval. We're looking for the difference in mean test scores between the third and fifth graders. And this is kind of my hint to tell me that I'm going to do third minus fifth. It's not the greatest indicator, but it's what I'm going to use as my indicator. So we have 30, 75, 3, 30, 84, 5, and 0.95. I went ahead and turned the 95% into a decimal. To be honest, I did that on autopilot. I wasn't even thinking, I just did it. My brain automatically sees a percentage and turns it into a decimal without even thinking about it. So this first 30 is the number of students in the third grade class. So I'm going to call that N1. I'm going to call that N1 a little further away. 75 is the mean of the third grade class. So that's going to be the sample mean of group 1, so X bar 1. 3 is the standard deviation of the third grade class, so that's going to be S1. The second 30 is the number of students in the second class, N2. 84 is their mean, X bar 2. 5 is their standard deviation, S2. And 95 is our confidence level. So we're just going to go right into our Excel spreadsheet. We don't need to calculate anything using our summary statistics because we were given everything. If we had raw data, we would need to go ahead and find any missing values that are not listed here before we go to Excel. So opening up Excel, we have our two sample interval and means. The M is the word means. It got cut off a little bit, but it's there. So X bar 1 is 75, S1 is 3, N1 is 30. X bar 2 is 84, S2 is 5, N2 is 30. That should not say alpha, that should say sea level. I apologize, I cannot fix that right now, but that should say sea level. And then our lower bound and upper bound. So we're going to write those down. So negative 11.1417, negative 6.8583. So we are 95% confident. Since Excel has done all of the math for us, it is this interpretation and the following interpretation that I'm going to be looking at, making sure we understand the most. We are 95% confident that the difference in mean test scores between the third grade and fifth grade graders is between negative 11.1417 and negative 6.8583. What does this actually mean? What is it actually telling us? The fifth graders scored on average between 6.8583 and 11.1417 more points than the third graders. So because the values from our intervals were both negative, that means the second piece was higher. We did third minus fifth, so that means the fifth graders had the higher values. And the values from the interval are telling us, on average, how much higher they're scoring. So the fifth graders are scoring between about 7 to 11 more points than the third graders. And if it's the same test, that's what you would expect. You would expect fifth graders to do better on a math test. I think it was a math test. Yes. Than third graders. If both of the numbers were positive, that would indicate that the third graders did better on the exam. And if one number was positive and one number was negative, then that would indicate to us that there is the possibility that the two grades could have scored the same on the exam. It's not a guarantee, it's a possibility, because there's the chance that the difference between the two classes is equal to 0, because 0 is in the interval. But that's not what we have here. We have both of the values are negative, which indicates that the fifth graders did better because I did third first, fifth was second. So I did third minus fifth. So that means the fifth graders are doing better on this test. And that is the confidence interval for the difference between two